Everybody see that?
Yeah.
Yeah, see it.
Okay, good. Good. Today we're going to talk about a little chemistry. And we're going to talk about metabolism and nutrition. So, sort of basic stuff here. Metabolism refers to all chemical reactions that take place in the body. The word metabolism is broken down into two subsets. One is catabolism, and the other is anabolism. Catabolism is the decomposition or breakdown of complex molecules into simpler ones. The opposite of that is anabolism. Anabolism is the synthesis or the combining of simple molecules to make more complex molecules. And really, this occurs throughout the entire body, but basically it occurs in the liver because the liver is the metabolic storehouse of your body. Metabolic reactions result from a balance of breakdown and synthesis. So it's a combination of anabolism and catabolism. And it produces energy. And the energy that it produces is ATP, adenosine triphosphate. So whenever you see the word ATP, it's energy. And you can kind of see here that ATP actually is the result of ADP, adenosine diphosphate, plus another phosphorus, making adenosine triphosphate. And we'll talk about these reactions because there are 4 important reactions that all of you should know, not only for the exam on April 1st, but you should know them if you're a biology major. Okay? When energy is transferred, it is transferred by oxygen reduction, also known as redox reactions. And they're a category of reactions that transfer energy. Oxidation is the removal of electrons. And when we talk about the human body and a removal of an electron, it is always hydrogen, H plus. So when H plus is removed from a molecule, it's called oxidation. And a typical example is the conversion of lactic acid to pyruvic acid. If you remove this hydrogen and this hydrogen, you're removing 2 hydrogens. Removal is called oxidation. The removal of 2 hydrogens from lactic acid will cause you to have pyruvic acid or pyruvate. Notice that this hydrogen and this hydrogen are gone. Okay? Where did they go? Where did they go? We'll talk about where they went. Where did those 2 hydrogens go? They got to attach to something, okay? And we'll talk about it as we go through this lecture. The opposite of oxidation is reduction. Reduction is the addition of electrons to a molecule. You're now adding hydrogen to a molecule. So if you convert pyruvic acid back to lactic acid, you are adding or reducing pyruvic acid by 2 hydrogens. You're now adding a hydrogen here, and you're adding a hydrogen here to produce lactic acid. And I'll tell you right now There are no chemical formulas on the exam. You don't have to know the chemical formula for pyruvic acid or the chemical formula for lactic acid, but you have to know the difference between reduction and oxidation. That's what's important here. Know the difference. When hydrogen is removed from a substance, it's called oxidation. And you liberate 2 electrons, and those electrons are called hydrogen. How does the body transfer those hydrogen atoms to another compound? Well, they use coenzymes. And there are 2 famous coenzymes that you have to understand. And these coenzymes are precursors of vitamins. Nicotinamide adenine dinucleotide, otherwise known as NAD. It is a precursor for nicotinic acid, which is a B vitamin. You also have flavine adenine dinucleotide, or FAD, which is a precursor to the vitamin riboflavin, which is a B vitamin. So both of these coenzymes, precursors of vitamins, transfer the liberated hydrogen from a substance that was oxidized. So what you're doing is you're taking that electron or 2 and you're adding it to the coenzyme. Now, when you add hydrogen to a coenzyme, it's the same as being reduced because you're adding hydrogen. So the 2 hydrogens that come out of oxidation of a molecule one is added to NAD, and NAD becomes reduced. And the other hydrogen is a free electron, FAD, when it acquires another 2 electrons, it becomes FADH2, and it is reduced. Remember, an oxidized coenzyme has no hydrogen on it because it's been removed. But when you add a hydrogen as an electron to a coenzyme, they become reduced. Anybody have any questions on that? This is a simple thing, but it can be very hard to understand sometimes.
Yeah, can you repeat the precursors to NAD?
Yeah, well, yeah. What it is the NAD and the FAD, they are both precursors to vitamins. The nicotinic adenine dinucleotide is a precursor to nicotinic acid. Flavin adenine dinucleotide is a precursor to riboflavin. Both nicotinic acid and riboflavin are both B vitamins. Did that answer your question? Okay, I want you to make sure you understand that both of these molecules, NAD and FAD, not only are precursors of vitamins, but they are coenzymes. They are coenzymes. Okay, that's important. Redox reactions, oxidation and reduction are always coupled, because one is always removing a hydrogen or an electron and adding a hydrogen or an electron. So that is extremely important to understand. Extremely important to understand. Okay? Now, let me ask all of you to answer this question if you can. If I remove two hydrogen from a molecule, where do you think those two hydrogen that are carried by the coenzymes are going to end up to make water? What do they have to attach to? You have two hydrogen floating around on these coenzymes, and you have to make water.
Oxygen?
Thank you. Thank you. That is called metabolic water. Metabolic water. It's made in the mitochondria of all cells. So the hydrogen electrons that come out of molecules will eventually attach to oxygen to make H2O, which is metabolic water. Some of the energy that is released during oxidation is captured when ATP is formed. So you have adenosine diphosphate plus a phosphate. This is called phosphorylation, and that energy becomes ATP. Now, ATP can be used immediately or stored, and it's stored in cells that have mitochondria in them. Okay? Name me a cell that does not have any mitochondria. You learned this already.
Is it a blood cell?
Yeah, it's a red blood cell. Red blood cells have no mitochondria because they have no nucleus. Because the function of red cells is to carry oxygen, period. That's it. And to get rid of carbon dioxide. Very, very well done. Let's talk about the metabolism of carbohydrates. Basically, carbohydrate metabolism is glucose metabolism. Without glucose, your body cannot function. It depends on the needs of the cell. What does the cell need? Does the cell need to produce energy as ATP? Does it need to synthesize amino acids? Does it need to synthesize glycogen? And does it need to synthesize triglycerides? So carbohydrate basically is mostly metabolism of glucose. Glucose passes through the plasma membrane to be used by cells. The only way glucose can get into the cells is by facilitated diffusion. It needs a carrier, and the carrier of glucose into the cell is insulin. And you'll learn a lot more about insulin when we talk about the endocrine system. But for this important point here is that facilitated diffusion brings glucose into the cell. Facilitated diffusion means that you need a carrier to bring it in, and that carrier is insulin. Without insulin, glucose will not get into a cell, and you'll have a disease called diabetes mellitus. That means your sugar in your plasma, because it can't get into the cell, will be extremely high. And there are many consequences of that disease, which we'll talk about in the endocrine system. Now, since carbohydrate metabolism is basically the oxidation of glucose to produce ATP, there are 4 sets of reactions involved, and you have to know all the reactions. You have to know glycolysis. You have to know the formation of acetyl coenzyme A, the Krebs cycle, and the ETC, which is the electron transport chain. You don't have to know them in detail. I'll tell you what you have to know about these 4 sets of reactions that oxidize glucose to produce ATP. Okay? Here are the 4 reactions. We'll delve into them separately, but let's look at the whole picture. The first is glycolysis. One glucose molecule is broken down into 2 pyruvic acids, producing 2 ATPs and 2 reduced NADs. Remember, you're adding a hydrogen, therefore it is a reduction reaction. And you have free hydrogen here, okay? Very important to understand. Pyruvic acid combines with acetyl-CoA to get you into the Krebs cycle. And we'll talk about the Krebs cycle. The Krebs cycle is the major producer of ATP, and we'll talk much more about it. Free electrons here, here, and here all go in to the electron transport chain. The electron transport chain. And in the electron transport chain, which is the total of all these reactions, you produce 26 to 28 ATPs. And the byproduct is electrons plus oxygen to give you water. And this water is called metabolic water. That's the overview. Let's delve into each of them, of the 4 reactions. Glycolysis is the process where a 6-carbon glucose molecule, C6H12O6, is split into 2 3-carbon molecules of pyruvic acid. Glycolysis involves 10 reactions. You don't have to know all those reactions. What you have to know is that glucose is split into pyruvic acid, leaving you with 2 ATP and hydrogen electrons. Okay? You don't have to know all this. Okay? You don't have to know all this. You don't have to know all of these words. You have to know this. I'm not going to ask you all of this. It's not important. It's not important. The end product is what's important. What happens to pyruvic acid depends on oxygen. This is called cellular respiration. If the amount of oxygen in the atmosphere is scarce, otherwise known as an anaerobic condition, pyruvic acid cannot be oxidized. Therefore, it is reduced. And when it is reduced, it is added to hydrogen atoms. And when you add 2 hydrogen atoms to pyruvic acid, it forms lactic acid. Lactic acid is never good. Never good. Okay? This is a bad situation for humans. Lack of oxygen is never good. And it converts pyruvic acid into lactic acid. When you have oxygen, plentiful, known as aerobic conditions, most cells will convert pyruvic acid to acetyl coenzyme A and will continue normal carbohydrate metabolism. This is the mitochondria. This is the mitochondria. And in an aerobic condition where there's plenty of oxygen, pyruvic acid will become coenzyme A. And without coenzyme A, you cannot enter the Krebs cycle. This is a key molecule. Without this molecule, you cannot enter the Krebs cycle. Here it is. Glucose becomes pyruvic acid, and in the presence of oxygen, pyruvic acid becomes acetyl-CoA, and that is the molecule that gets you into the Krebs cycle. The Krebs cycle is also known as the citric acid cycle. It occurs in the matrix of the mitochondria and consists of 8 reactions. No, you don't know. You don't have to know the 8 reactions. But I want you to know the outcome of the Krebs cycle. I would never ask you these words. You don't have to know these words. You should have learned them in high school, actually. But here's the Krebs cycle. It occurs in the matrix of the mitochondria and produces the majority of ATP. It starts with acetyl-CoA. That you have to know. And continues. And the outcome is electrons and ATP. And then you get into the electron transport chain, the ETC. It is a series of electron carriers in the mitochondria. Each carrier in the chain is reduced because it picks up electrons and is also oxidized as it gives up electrons. The side effect of all these reactions is the release of heat. And when you have a reaction that releases heat, it's called exergonic. Exergonic. And it's used to form ATP. ATP. Okay? That is very important. Here is the electron transport chain. Here it is. Okay? In the electron transport chain, there are electron carriers. And there are 2 major carriers here. And they are the first 2. So the first 2 I want you to know. Flavine mononucleotide, FMN. It is a precursor to riboflavin, a B vitamin. And the other is cytochromes. Cytochromes will carry electrons in the electron transport chain. Okay? The electron transport chain is in the inner mitochondrial membrane. Remember, the Krebs cycle is in the matrix. But when you get into the inner mitochondrial membrane, that's where the electron transport chain happens. And in this chain, there is complexes that act as a proton pump. Whenever you see the word proton pump, you should always think that it expels hydrogen because this is the proton. Here it is, hydrogen. So the proton pump will always expel hydrogen. And what is hydrogen attached to? It attaches to oxygen to make metabolic water. That is very, very important. Okay, so the combination of all these reactions is called cellular respiration. It will generate 30 to 32 ATPs, which is energy, for each molecule of glucose that is catabolized or broken down. Here is the reaction. Glucose in the presence of oxygen will yield 30 to 32 ADPs and 30 to 32 phosphoruses. This will equal a byproduct of carbon dioxide, water, and ATP. Okay? That is cellular respiration in a nutshell. Here it is again. One molecule of glucose in the presence of oxygen becomes pyruvic acid. In the presence of oxygen becomes acetyl coenzyme A. It allows you now to enter the Krebs cycle, which is in the matrix. I'm sorry, which is in, oh, I am right. It's in the matrix of the mitochondria. Getting into the Krebs cycle will produce electrons that are captured by the electron transport chain, which is in the inner mitochondrial membrane, which will produce ATP and water. Those are the positive things that it does. And this is a summary. This is a summary. It's probably a good summary to look at. Glucose that is not needed will be stored. And it's stored as glycogen. And that process is glycogenesis. When ATP is needed, the stored glycogen is broken down by a process called glycogenolysis. So know the difference between glycogenesis and glycogenolysis. Okay? Basically, here it is. Here's glucose. In the presence of enzymes, which you don't have to know, you form glycogen, which is stored, okay? If you need it, it's broken down as glycogenolysis. If you need to build it up, it's stimulated by insulin. You don't have to know the hormones here. You don't have to know the hormones here. The hormones we'll talk about in greater detail in the endocrine system. Again, you don't have to know the hormones. I'm not going to ask you any hormone questions of this nature on exam number 3. Okay, let's go from carbohydrate metabolism to fat metabolism. Because most lipids are nonpolar, they do not dissolve in water. They cannot be transferred through the plasma membrane without attaching to a protein. So lipids cannot come into the cell without proteins. The combination of lipids and proteins is called a lipoprotein. And that's how fat comes into the cell, attached to proteins as a lipoprotein. Okay? And here is a lipoprotein. It is a combination of protein and lipid. And there are 4 classes of lipoproteins. And you've heard of some of these, but here's a new word, chylomicron. Chylomicron is the transport of dietary lipids, fat that you eat, to adipose tissue. VLDL, the transport of triglycerides from liver cells to fat cells. But more importantly are these two, LDL and HDL. You've heard of them before. Low density lipoproteins is 70% of your total cholesterol. And HDL, which is the other 25%, they remove excess cholesterol from body cells and take it to the liver for elimination. So know the 4 classes of lipoproteins. Where do you get cholesterol from? Food. Eggs, dairy, organ meats, and most of your cholesterol is synthesized by your liver cells. And it's always bad. It's always bad. Increases in total cholesterol are associated with coronary artery disease. You kind of learned that in the cardiac lectures. Exercise, diet, and certain drugs are used to reduce high cholesterol levels. And remember, HDL is good and LDL is bad. HDL, the high density lipoproteins, is known as happy, and LDL, the low density lipoproteins, is known as lousy. So that's how you know the difference between HDL and LDL. Fat can be oxidized to produce ATP. If you need it, you will produce energy from adipose tissue or fat tissue. If you're starving to death, your body will oxidize fat to produce energy to keep you alive, Okay? Lipid catabolism is called lipolysis, the breakdown of lipids into fatty acids and glycerol. So splitting triglycerides, the process called lipolysis, makes fatty acids and glycerol. To build up lipids in your body from glucose or amino acids, that is called lipogenesis, to make fat from glucose and amino acids. What happens when you break down fat? When you break down fat, you have byproduct. Here's fat, triglycerides. When you break down fat, you have fatty acids and glycerol. Okay? These fatty acids can also be further broken down into what is called ketones. And ketones is a byproduct of lipolysis. Breaking down fat will give you ketones in your bloodstream. Ketones in your bloodstream is never good. It's never good. And you'll spill it in your urine. That's how we know that you're starving. That's how we know you're breaking down fat. That's how we know you're losing weight. We check your urine, and in your urine, we find ketone bodies. Ketone bodies. Not only that, these items in your urine make your urine smell like fruit. Ketone bodies have a sweet smell to them. So if you're urinating and you smell something sweet, that means you have ketone bodies in your urine. That means you're breaking down fat. You're either starving, fasting, or you've got an endocrine disease. No, basically, you have diabetes. Okay, carbohydrates, lipids, and now proteins. Please understand that proteins are not stored. You do not store proteins. All digested proteins are broken down into amino acids. They're either oxidized to produce ATP or they're synthesized to produce new proteins. They are never stored. The majority of proteins in your body function as enzymes. They function as antibodies, gamma globulin. They function as proteins that clot your blood. They function as hormones, or they function as muscle fibers. They are never stored. The breakdown of protein produces amino acids. It also produces fatty acids, and it also produces ketone bodies. Protein anabolism, or the synthesis of proteins, creates new amino acids. Protein metabolism produces from the Krebs cycle all the amino acids. Here are all the amino acids except for a few. There are a few missing. No, they're not. Here, I found them. These are the 20 essential amino acids that are produced in the Krebs cycle. And no, you don't have to know all the amino acids. But this is very important. What are the key molecules at the metabolic crossroads? There are three, and there are three chemicals. And these chemicals are G6 phosphate, pyruvic acid, and acetyl-CoA. Without these molecules, you cannot make any energy. Glucose 6-phosphate, pyruvic acid, and acetyl-CoA. Three of the molecules at the metabolic crossroads in your cells. G6 phosphate is involved in the making of glycogen. Whenever you make glycogen, if you need sugar, glycogen is broken down. So without glucose 6-phosphate, you can't make glycogen, and therefore you have no source of glucose when you need it. It is also important in the synthesis of nucleic acids, RNA, DNA, and it is involved in glycolysis. Pyruvic acid, remember, in the presence of oxygen, becomes acetyl-CoA. If you don't have oxygen or you lack oxygen, it'll produce lactic acid. It'll produce lactic acid. So pyruvic acid is extremely important. And it will produce glucose. Glucose. Gluconeogenesis, a word that means that you get glucose from non-carbohydrate substances. Gluconeogenesis breaks down amino acids and lipids into glucose, not carbohydrate metabolism. Gluconeogenesis means that you're getting glucose from non-carbohydrate substances, and those two are amino acids and lipids. Acetyl-CoA. Remember, without acetyl-CoA, you cannot enter the Krebs cycle. And here we have them all together. Here's glucose 6-phosphate. Here's pyruvic acid. And somewhere around here, here it is, acetyl-CoA. There it is. Essential molecules. And this is a review. I would look at this review. I'm not going to talk about adaptations. That's not important as we go through this. It's not important. You don't have to know the hormones. Not important. But you should know the difference between fasting and starvation. When you fast, you're going without food for a few hours or several days. When you starve, you go without food for weeks or months. So that's very, very important to understand the difference. When you fast and when you starve, you will break down fat. You will have lipolysis of your fat cells. And a byproduct of lipolysis is ketone bodies. And ketone bodies will appear as energy and broken down, and the byproduct will be in your urine. And you'll have ketone bodies in your urine, and your urine will smell basically like fruit or alcohol. BMR. The metabolic rate is the overall rate at which metabolic reactions that use energy occur. It is measured when the body is quiet, resting, or fasting. This is known as the BMR, the basic metabolic rate. Factors that affect the metabolic rate, otherwise known as heat production, are all of these. Obviously, if you exercise, you will affect your basic metabolic rate. If you have a hormone problem, if you're hyperthyroid or hypothyroid, you'll affect your basic metabolic rate. If you're sleeping in a coma, it'll affect your metabolic rate. If you have a high temperature or a low temperature, it'll affect your basic metabolic rate. The ingestion of food, obviously, your age, your gender, the climate, if you're sleeping, and if you're malnourished. All of these affect your basic metabolic rate. I want you to know these 4 words: heat transfer. How does the body transfer heat? Conduction. Conduction is from one cell to the other. They touch each other. Conduction. Convection is by the air. There are waves of heat coming through the air. Radiation, the heat transfer basically is from electromagnetic waves. And evaporation is from one solid changing to a liquid and then changing to a gas. So those are the four ways to transfer heat: conduction, convection, radiation, and evaporation. Okay? You should know, you probably learned a little bit about this in AP1, but for those who have not taken AP1, the hypothalamus controls your temperature. And the preoptic area of your hypothalamus is your body's thermostat. Energy intake is directly dependent on the amount of food you consume. And your total energy expenditure is based on the metabolic rate at rest, which is 60%, your physical activity, which is 30 to 35%, and the amount of food that you take in, which is around 10%. In the hypothalamus, there is controls of hunger. The arcuate nucleus and the paraventricular nucleus in your hypothalamus basically control hunger. But there are other things in your body that control hunger. And one of these is very important. And the one that's important is leptin. There's a hormone produced by adipose tissues. Adipose tissues, fat cells, produce leptin. And leptin will tell you when to stop eating. So in combination with the hypothalamus, the arcuate nucleus, and the paraventricular nucleus, the hormone leptin in your fat cells will control hunger. The other two are not important. Okay? But what is nutrition? Well, what are nutrients? Well, the nutrients are chemicals in food that cells use to grow, to maintain, and to repair. All these nutrients include water, carbohydrates, lipids, proteins, minerals, and vitamins. Which do you think is the most abundant out of these 6 in your body?
Water.
Yes, water. Basically, water is always the answer. Okay? 90% of nutrients in your body is water. All right? We talked about carbohydrates. We talked about lipids. We talked about proteins. And now we're going to talk about minerals and vitamins. Okay? There is a good review in this lecture. Okay? And the review is actually this slide. There it is. ChooseMyPlate.gov. This is the substances other than water that you need for survival. You need fruits. You need vegetables. You need grains. You need protein. And you need dairy to have a balanced diet. Those are the 5 items that you need. And we're going to talk about these items when we talk about vitamins and minerals, because this is where you get vitamins and minerals from, these 5 essential items. Okay? Minerals. Minerals are inorganic elements that play an important role in maintaining a healthy body. Vitamins are nutrients. They are required to maintain growth and normal metabolism. They cannot be synthesized by your body and must be consumed in foods. This is a review. I'm going to talk much more about them, but you can always refer to this as a review. I'm just going to skip it because I'm going to give you a lecture on nutrients and vitamins and minerals. Any questions on that as we go into the next lecture? Okay. I didn't like the way your textbook presented vitamins and minerals, so I'm giving you this lecture to supplement the chapter number 25. Okay, here we go. Vitamins. Vitamins are organic compounds, carbon-based compounds, needed for normal function, growth, and maintenance. They are all cofactors. They don't do anything by themselves. They are not broken down. They are not a source of calories, and they will not make you gain weight. You can buy these vitamins at any vitamin store. There's hundreds of vitamin stores, okay? But please realize that you can usually get vitamins from the food that you eat. You don't need to have extra vitamins unless you have a poor appetite or have some medical problem. But realize that if you're going to buy vitamins, they are degraded by heat, light, bacteria, oxidation, enzymes, and insects. There are requirements that all vitamins have to have on their labels. This is vitamin water, a water that has vitamins in it. And it must tell you, here it is, it must tell you what's in it. What's in it, okay? The daily recommended intake, the daily values, the daily recommended values, it must tell you what's in everything that you buy today. The Food and Drug Administration has regulated the requirements of most vitamins. So what is your requirements? Well, as you get older, your appetite, your preferences may change, and you may need to take vitamins. If you are a female, you may need to take extra vitamins. If you're pregnant, you may need to take extra vitamins. If you're breastfeeding, you may need to take extra vitamins. The daily reference value is a standard established for proteins and constitute a part of the label that's on every package of vitamins. Okay? So let's talk about the vitamins. Vitamins are divided into fat soluble and water soluble. These are the 4 fat soluble vitamins: A, D, E, and K. If you cannot remember those 4 vitamins, remember the postal abbreviations for Alaska, AK, and Delaware. DE. So it's the fat soluble vitamins are Alaska and Delaware. AK, DE, ADEC. Vitamin A. Vitamin A is an oxidant. It's an antioxidant. Vitamin D we'll talk about, vitamin E we'll talk about, and vitamin K we'll talk about. Vitamin A, no, I'm not going to ask you a chemical formula on exam number 3. Vitamin A is known as a carotenoid. The word carrot. It's used as a colorant. It's used to make things orange. It is an antioxidant. It gets rid of the free electrons. And what are those free electrons? Hydrogen. It gets rid of them. It reduces them to make metabolic water. That's what an antioxidant does. Vitamin A is stored in your liver. It is important for sight. A deficiency causes night blindness. You have trouble seeing at night. And where is it more common? Because it's a carotenoid, it's more common in carrots. So vitamin A is extremely important. In today's world, you just don't have to eat carrots. We have engineered putting vitamin A into rice. So today's rice has fortification with vitamin A. An overdose of vitamin A is called carotenosis. And guess what? Your skin turns orange. Vitamin D, another fat-soluble vitamin, also known as calciferol. Vitamin D has a role in calcium absorption. Without vitamin D, you cannot absorb calcium from your food. It maintains calcium and potassium levels. It's the only fat-soluble vitamin that we make in the presence of sunlight. It can also be made from cholesterol. It's stored in fat. People that for some reason don't get enough sunlight, whether they be people that stay inside the house or people that are shut in, risk a vitamin D deficiency. We have fortified milk and cereal with vitamin D so that even shut-ins can get vitamin D. The toxicity is horrible because it will make you absorb more calcium, and when you absorb more calcium, you get kidney stones. You get heart disease and blood vessel disease. So that's vitamin D, okay? A lack of vitamin D is called rickets. It's called rickets. It is a lack of calcium absorption, and it causes bowed legs. Bowed legs. Because there's not enough calcium absorption in your body. And this is a picture that I took when I was in Saudi Arabia, because the Saudi women are not allowed to show their faces in public. And I always wondered about vitamin D problems with these women. I haven't proven anything yet, but I just show you that picture. Vitamin E, another fat-soluble vitamin. It is the strongest antioxidant vitamin there is. It is essential in blood thinning. It reduces stroke. It reduces cancer. It reduces heart disease. It will bolster your immune response. We spend a fortune on vitamin E because of its good effects to prevent heart disease and stroke. Vitamin K, you already learned about vitamin K. Vitamin K is essential in blood clotting. Now, let's go to the water-soluble vitamins. The famous water-soluble vitamin is vitamin C. Vitamin C, it is added to everything. It's added to every cereal you pick up. It is cheap and is added to everything, okay? The other water-soluble vitamins are the B vitamins. So here you have a list: B1, B2, B6, B12, biotin, pantothenic acid, niacin, folate, and vitamin C. So let's talk about the water-soluble vitamins. Vitamin B1, also known as thiamine. Thiamine is important in carbohydrate metabolism. It helps you metabolize glucose. It affects your central nervous system. A deficiency of thiamine will give you a horrible neurological disease called beriberi, the inability to walk. The word beriberi comes from the Singali or the Sinhalese dialect, and it means I can't, I can't. Vitamin B2, riboflavin. Okay? This is where you get flavine adenine dinucleotide, a precursor of riboflavin. So it is involved in carbohydrate metabolism. It's involved in energy. Vitamin B2, riboflavin. Vitamin B6, pyridoxine. It is a neurotransmitter. So it's involved in the nervous system. Vitamin B12, you already learned about vitamin B12. Vitamin B12 is cyanocobalamin. It is involved in the development of your red blood cells. Lack of it makes you anemic. This is the vitamin that if you are a true vegan, it's almost impossible to get from eating vegetables. You must take a supplement if you are a vegan to give you vitamin B12. You can't get enough B12 from vegetables and fruits. Vitamin B7, also known as biotin. Biotin is involved in fatty acid synthesis. Pantothenic acid, vitamin B5, it is also involved in the metabolism of alcohol, carbohydrates, proteins, and fat. Folate, vitamin B12. You have already learned about folate. Folate is also involved in the production of red cells. A folate deficiency will give you a macrocytic anemia. Not only that, it is also involved in the neurological cell membranes. If you have a lack of folate when you are pregnant, your baby will be born with a neural tube defect right here, a neural tube defect. This baby could be paralyzed from here on down. Not necessarily, but could be. All right? So those are the B vitamins. Let's talk about vitamin C. Vitamin C is known as ascorbic acid. It's added to everything. Its deficiency of vitamin C causes bleeding gums and hemorrhages. It is found in citrus fruits, oranges, lemons, limes. The English people who boarded ships were called limeys because to get vitamin C on a 2-month journey, they brought limes with them as a supplement for vitamin C. So that's why they're called limeys. Scurvy is a disease with a lack of vitamin C. It causes bleeding gums and bruising. The word is scurvy, and is treated with vitamin C, and it goes away. Niacin. Niacin is known as B3. It is involved in energy. Nicotinic acid, niacin. A disease of lack of niacin is known as pellagra. And pellagra is known as a disease of the 4 Ds: dermatitis, problems with your skin, diarrhea, dementia, and death. Pellagra, a lack of niacin, a lack of niacin. Those are the vitamins. Let's talk about the minerals. The minerals are divided into macro and minimal. The big minerals, the 7 that are here, are the ones that are very, very important. I'm going to ask you questions on the macro minerals. Focus on the macro minerals. Yes, there will be questions on the other minerals, but these are the most important. I will go over all the minerals, but the macro minerals are the most important. And they are phosphorus, calcium, chloride, magnesium, potassium, sulfur, and sodium. Minerals are required for everything: nerve conduction, muscle contraction, fluid balance, acid-base balance, and skeletal structure. Before we go on, can someone tell me the most abundant mineral in your body?
Is it calcium?
It's calcium. Calcium, because calcium is in your bones. So that's what's important about the minerals. Here it is, calcium. Calcium is found in a lot of things, but basically it's found in milk. And if you're a true vegan, you have a problem getting calcium. Calcium is also in nuts too, so you can get a little bit in nuts. But if you're a true vegan, I would recommend you take calcium supplements. As we said before, vitamin D is essential in the absorption of calcium. Very important. It is the most abundant of all the minerals. Not only that, it's the 5th most abundant element in your body. It's needed by all cells. It's found basically in bone, and it's found as hydroxyapatite crystals in your bone. Here it is. Here's number 1, oxygen. Number 2, carbon. Number 3, hydrogen. Number 4, nitrogen. And boom, number 5, calcium, the fifth most common element in your body. It is controlled by the parathyroid hormone, calcitonin, and vitamin D. I'm not going to ask you any hormone questions when it comes to minerals. Don't worry about the hormones. We'll talk about them in the endocrine system. But the function of calcium is all throughout your body. You can't clot blood without calcium. You can't have a synapse in your nerves without calcium. So calcium is an extremely important mineral. You can't relax or contract your muscles without calcium. So calcium is extremely important. And basically it comes from milk. Basically it comes from milk. A lack of calcium as you grow older is known as osteoporosis. Here's the normal bone, and here is osteoporosis. You have holes in your bone, and that's why as you grow older, you start to shrink. You start to shrink, especially in women, especially in women. A very common disease in elderly women is osteoporosis. It's absorbed with vitamin D. That's what's important. Don't worry about all the rest. It's excreted in your feces, basically, and in your urine. Don't worry about the RDAs. I'm not going to ask you the RDAs of anything. Just know the generalities of calcium. You don't have to know these supplements either, but you can buy them over the counter at a vitamin store. Sodium. Sodium is the principal cation in extracellular fluids. We're going to talk about sodium again when we talk about fluid and electrolyte balance. Sodium is essential in equilibrium. It's essential in acid-base balance. It's essential in muscle irritability. It's readily absorbed. It's excreted in your urine and your sweat. Remember, there are 4 systems that get rid of waste, and one of the waste is sodium chloride. Your respiratory system gets rid of waste, CO2. Your GI system gets rid of waste. It's called feces. Your urinary system gets rid of urine. Majority of waste is through your urine. And your skin gets rid of waste in the form of sweat. Don't worry about the RDA, that's not important, but worry about the excess of sodium. If you have too much sodium in your body, you will have edema, swelling of your legs. If you have too much sodium in your body, your blood pressure will rise. That's what's important about sodium. Too much is bad. Too much is bad. Okay? And if you don't believe that, I want you to eat a sodium-rich meal. And in 6 hours after that meal, weigh yourself. You'll weigh more. You'll weigh more. And then the next day, it'll go away. Okay? So that's what sodium does. Sodium causes edema, excess fluid, and causes high blood pressure. Don't worry about where you can get sodium from, but this is why the Florida Gators invented Gatorade, because they knew that you lost a lot of sweat when you exercised, and Gatorade replaces the sodium that you lose, and also the water that you lose from sweat. Potassium. Potassium is the principal cation in intracellular fluid. And we're going to talk much more about it when we talk about acid-base balance and fluids. Okay? It has many, many functions, many functions. Its sources are right here: bananas, vegetables, meats, whole grains. But what they don't tell you is that bananas are a rich source of potassium, but there's another fruit that has more potassium in it. Does anyone know what that fruit is? It's a very rarely eaten fruit, but it has more potassium than bananas. Somebody. Are you still there?
Yeah, we just don't know what has more
Oh,
potassium.
okay, I just want to make sure you're still here. It's apricots, okay? Apricots, all right? And just like potassium, just like sodium, it's excreted by the urine. Don't worry about RDAs, that's not important. A deficiency, otherwise known as hypokalemia, basically causes severe vomiting and diarrhea, okay? And the symptoms of hypokalemia is muscle weakness. And the heart is a muscle, so it will also be weak. So muscle weakness is a sign of hypokalemia. Excess potassium, I think I asked this question on exam number 2. I could kill you within seconds by injecting you with potassium. Okay? It causes horrible cardiac abnormalities. It will stop your heart. It will stop your heart. You can buy it over the counter. Don't worry about that. I'm not going to ask you any of these supplements. I'm not going to ask you how to treat hyperkalemia. That's not important. I give this lecture to nurses too. Chloride, an essential anion. Why do you think chloride is so important? What if I told you it is very important in the stomach? Why is chloride important in the stomach?
Is it for like a pH balance?
It's for a pH balance, but what it does, it forms hydrochloric acid. Without chloride, you can't have hydrochloric acid. So that's why chloride attaches to hydrogen and makes hydrochloric acid. It's essential in the stomach. A deficiency is very rare. Do not worry about it. What I want you to know about chloride is that it's essential for hydrochloric acid. Phosphorus, wherever calcium goes, phosphorus goes, and everything rich in calcium is rich in phosphorus. And these are the food that is rich in calcium and phosphorus: milk, cheese, eggs, beans, and fish. And the only time a vegan would get calcium and phosphorus is to eat beans. And you can't eat enough beans to get enough calcium and phosphorus. So a vegan should not only take vitamin B12, but should also take calcium and phosphorus supplements. Okay? Phosphorus is the second most abundant mineral in the body because it goes with calcium. So calcium and phosphorus are number 1 and number 2 when it comes to minerals in the body. Don't worry about deficiency. It's not important. Magnesium. Magnesium is the second most plentiful cation in the intracellular fluids. It is essential in muscle and nerve conduction. That's why calcium is important. Sorry. That's why magnesium is important. Muscle and nerve tissue. Muscle and nerve tissue. It functions as a coenzyme. People that are alcoholics will develop hypomagnesemia. They will develop irritability. They'll develop disorientation. They will develop seizures. So if you are an alcoholic, you lack magnesium. And the treatment of irritability and convulsions in a alcoholic is to give them magnesium. Also, when you are pregnant, you have a decrease of magnesium in your system, and you can develop seizures from it. And the treatment of a disease called eclampsia in late-term pregnancy is treated with magnesium, because magnesium is the cause. Hypomagnesemia is the cause of eclampsia in pregnant females. Basically, magnesium comes from meat or green plants. Sulfur. Sulfur is a macro mineral that's important in the production of sulfur-containing amino acids. And there are 3 sulfur-containing amino acids in your body: cysteine, cysteine, and methionine. That's why sulfur is important. The trace minerals. Remember, I want you to know the macro minerals. The trace minerals are iron, zinc, copper, selenium, iodine, chromium, fluoride, cobalt, molybdenum, boron, and manganese. These are the 11, but I only want you to know iron, zinc, iodine, fluoride. I want you to know iron, zinc, iodine, and fluoride. That's what I want you to know, and we'll go through them. But I want to talk about the others, but I'll have no questions on the others. The questions will be on iron, zinc, iodine, and fluoride. Zinc. Zinc has an important role in enzymes. Look here. Here's an important enzyme, ACE. You learned about ACE, angiotensin 1 converting enzyme, because it is the enzyme that converts angiotensin 1 into angiotensin 2, causing you to have a rise in your blood pressure. Look here, carbonic anhydrase. Another important enzyme, H2O plus CO2 equals H2CO3, catalyzed by carbonic anhydrase. Iron. One of the ones I want you to remember. You learned about it in the blood system. You learned about iron. Iron is important in the transport of oxygen. A low iron causes iron deficiency anemia, the #1 anemia in the United States. Don't worry about 2 types of iron. That's not important. How is iron absorbed? It's absorbed like everything else in the small intestine. In the small intestine. It's carried in the bloodstream. It's carried by proteins, and one of the proteins you already learned is ferritin. Ferritin carries iron. It's stored in the liver. It's stored in the spleen. It's stored in the bone marrow because it is essential in making hemoglobin. Remember, hemoglobin is iron plus globin. That's why iron is so important. Iron is usually lost in your stool. It's not lost in your urine, and it's not lost in your sweat. You can also lose it when you bleed, either vaginally or in your gut. And when you are losing iron in your GI system, your stool or feces will turn black. So a sign of iron loss in your feces is that you'll have black stool. So that's important. Okay? An iron deficiency will cause you to be anemic. It'll cause you to have fatigue, dizziness. Here's a normal sphere. Here is iron deficiency. Iron deficiency. You already know this. Okay? The most common cause of iron deficiency is blood loss. Blood loss. That's the most common deficiency. How do we diagnose it? Don't worry about how you diagnose it. It's not important. If you are menstruating, you need supplementation of iron because every cycle you lose iron as you bleed. If you are pregnant, you also lose iron. You're losing iron to your baby. So women that are pregnant or menstruating need iron supplementation. Okay? Don't worry about the different types. How do we treat iron deficiency? Iron. You have iron pills. Iron pills. Copper is a trace mineral that is involved in enzymes. I'm not going to ask you any questions on copper. Don't worry about copper, but worry about fluorine. Fluorine is essential in your tooth development. It has been proven that water that has been fortified with fluorine will give you better teeth, less dental caries, stronger bones, and a reduction in osteoporosis. Okay, so this is what we add to the water supply to give you better bones and better teeth. Fluorine. Fluorine. Its major source is drinking water, but also spinach, lettuce, and onions. Iodine, another important mineral that I'm going to ask you questions on. You will learn in the endocrine system that without iodine, you cannot make thyroid hormones. Thyroid hormones, known as T3 and T4, are a combination of the amino acid tyrosine and the mineral iodine. Extremely important for thyroid gland maintenance. Without iodine, your thyroid gland will enlarge because you're not making enough thyroid hormones, and you'll get what's called a goiter. And the number one sources of iodine is fish and seaweed. So if you love sushi, you got plenty of iodine. In today's world, it is added to salt. So you can buy iodized salt, which has iodine in it, to get your supplements of iodine. Okay? Silicon is basically a trace mineral that is not important. Manganese is another one that's involved in enzymes, not important. Chromium is also involved in the production of insulin and the glucose getting into your cell, but I'm not going to ask you any questions on it. Selenium is another antioxidant that I'm not going to ask you any questions on. Cobalt, the only thing important about cobalt, though I'm not going to ask you any questions on it, is that it is necessary to form vitamin B12. Remember, vitamin B12 is cyanocobalamin. The cobalamin part is cobalt. Molybdenum, hard word to say. I'm not going to ask you any questions on it. Boron, essential in bones. There'll be no questions on it. And the difference between fortification and enrichment. Fortification means that we are restoring lost nutrients due to processing. When you process food, you lose nutrients. So fortification is restoring those nutrients lost during processing. Enrichment means that we're adding nutritional value to meet a specific standard. So you have enriched bread, enriched flour, which we're adding things to, like iron or thiamine or folic acid. That's what's the difference between fortification and enrichment. And I knew that was the last slide. Great.
Professor,
Go.
can I leave early today?
Not only are we going to leave early, we're going to leave now. How about that?
That's awesome.
Isn't that awesome? Perfect timing, huh?
Yeah, I got a meeting with a professor coming up.
No problem. Any other questions? I know this was a long day, but any other questions we have? Basically, I want you to know the macro minerals and only a few of the trace minerals. Okay? And this is why exam number 3 is going to be 100 questions. There's a lot of material here. So next week, we will go over the urinary system acid-base balance. All right? Stay dry. I'll see you next week.
Have a good one, Professor.
Have a good one.
Peace
Thank
out.
you, Professor.
Peace out.
Have a great weekend, Professor. See you.
You too, guys. Take care.